I was looking at a picture of one of those massive extension ladders the other day, and you just marvel at the physics of it. That sheer vertical reach.
But even that doesn't come close, does it?
Not even a little bit. Because nothing, and I mean nothing in history, touches the biological record holder for neck length. The Mamenchisaurus dinosaurs.
You're so right. We're about to get into a true engineering marvel. We're talking about animals like Mamenchisaurus youngii, where its neck made up, what, an incredible 41% of its entire body length.
41%. Okay, let's just stop there for a second. How is a structure like that even possible? That's what we're going to unpack in this deep dive. How on earth it didn't just collapse under its own weight.
That's the central question, really. The solution starts with something that sounds almost like science fiction. It's a biological trick called pneumaticity.
Pneumaticity. So basically, air pockets inside the bones.
Exactly. The vertebrae were filled with them. It's this incredible strategic removal of bone to optimize weight.
So what did that do in terms of, the actual mass?
It made the neck shockingly light. The estimated density was as low as zero 0.5 grams per cubic centimeter. They weren't just bones. They were this internally reinforced, super lightweight scaffold.
Okay, so you solved the weight problem. But then you have a new one. A long, light structure is usually, flimsy. They must have needed incredible stiffness.
And they had it. That brings us to the cervical ribs. These incredibly long, overlapping bones that run right along the neck.
They look like they're just holding everything up.
That's what you'd think, but it's more clever than that. The research shows they aren't really ribs in the way we think of them. They're actually ossified tendons.
Wait, tendons made of bone, so they weren't for compression, for pushing up.
Precisely. They were built for tension. Think of them like steel cables on a suspension bridge running along the neck to keep it rigid. It stopped the whole thing from wobbling side to side when the animal walked.
A stiffened, lightweight beam.
Okay.
But how did they use it? Because you always see the drawings of them with their heads way up high, like a giraffe on steroids.
That classic image is, it's a myth. It just doesn't work biomechanically. Stress analysis on the joints shows that a horizontal posture, or maybe a shallow incline of 20 to 40 degrees, was far more stable.
And there's the blood pressure issue, right?
Oh, absolutely. Pumping blood 8 meters straight up would require blood pressure over 600 millimeters of mercury. It's not physiologically plausible.
So the length wasn't for reaching high, it was for reaching wide.
Exactly. They were specialists in efficient horizontal foraging. That neck was a giant sweeping tool that let them graze a huge area without moving their massive bodies.
That saves an incredible amount of energy.
Up to 80%, according to some estimates. It's basically ancient biological automation, moving the tool instead of the whole factory.
Speaking of optimizing complex systems, this is a great time to thank our sponsor, Embersilk. If you're looking to optimize your own world with AI, be it training, automation, or custom software development, Embersilk helps you find where AI agents can make the biggest impact. Check them out at embersilk.com for your AI needs.
So we've got this amazing horizontal feeding machine, but that efficiency creates another huge biological problem. Breathing. You have this 9-meter-long trachea. That's an enormous volume of dead space air that never gets to the lungs.
That sounds like it should have been a fatal flaw. How did they solve that?
They had to have what we call an avian-style respiratory system. An ARS, it's what modern birds have.
Which means the air flows in one continuous direction.
Exactly. It uses a series of large air sacs, which conveniently fit perfectly into those pneumatic cavities we talked about, to keep fresh, oxygenated air constantly flowing over the lungs.
Wow. So the thing that made the neck light also made it possible for them to breathe.
It's a perfect example of how different evolutionary traits can reinforce each other. The pneumatic bones, the stiffening tendons, the hyper-efficient breathing. It all came together to create this uniquely successful animal.
What a beautiful, integrated solution. It wasn't an oddity, it was a high-performance tool. Evolution is the ultimate creative engineer.
And it leaves you with a thought,
Yeah.
The next time you see any tall structure, think about the unseen engineering inside it. The air-filled bones, the tension cables. It makes you wonder what other elegant solutions are still waiting to be discovered in life's blueprints.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.